All right, friends and neighbors, let's talk a little bit more about network math. And today's calculation or calculations are the complements. Not compliment like, oh, these are such wonderful videos, thank you very much for sharing. No, these are the complements that we use in numerical calculations. So what is a complement and why do we care? Well, first up, do you remember complementary angles? So these are two angles that come together and form 90 degrees. So A there is going to be the complement of B, and B is going to be the complement of A. So these add up to something which makes them complementary. In this case, they add up to 90 degrees. Well, the ones and the twos complement are very similar to that idea. They add up to a particular value, in this case, all ones. And that'll become important to us later on. So to start, the ones complement is simply the opposite of the bit pattern that you have. So if you invert all of the bits, you get the ones complement. So I've got a couple of examples here, 0, 0, 0, 1. The complement to that is 1, 1, 1, 0. And 0, 1, 1, 1 is 1, 0, 0, 0. Okay, so pretty straightforward. And so it is just the inverse, right? And we're trying to get all ones. If you took those two things and added them together, you would get all ones. Now the twos complement, very similar idea, but what we're going to do is take the inverse or the ones complement and then we're going to add 1. So if we took 0, 0, 0, 1 and we just inverted it or did the ones complement, we would get 1, 1, 1, 0. But if we add 1, we get the twos complement. And the same thing is true going back the other way. 0, 1, 1, 1 would be 1, 0, 0, 0, but we add 1, so we get 1, 0, 0, 1. All right, fabulous. So that's the two complements. What do we do with them? So where is the ones complement used? Well, we use the ones complement in checksums. So that's actually why we started talking about complements in the first place. We did CRC and then we were going to do checksums, but then we realized that checksums use the complements, and so the ones complement, actually the ones complement of the ones complement sum, is used in checksums. And as an example from RFC 791, the Internet Protocol, the header checksum, which is 16 bits long and appears in every single IP packet, can be described as follows. A checksum is on the header only, so it's a chunk of the packet, doesn't include the payload. Some of the header fields change, and this is recomputed and verified at each point along the pathway. So the example that they give in the RFC is that the time to live field is decremented by every router. So the algorithm goes something like this. The checksum field is the 16-bit ones complement of the ones complement sum. So you take all the 16-bit words, and we're going to do some addition with them, and then we're going to take the complement. Now I've added a note here on network address translation. Network address translation is important to us as far as the checksum goes because we even change the IP addresses when we do translation. And so the checksum is based on the ones complement or the ones complement of the ones complement sum. So that's where the ones complement appears. It appears all over the place when we do checksums. Well, how about the twos complement? Well, the twos complement is how we do some computation and how we represent negative numbers. Remember that we don't actually subtract in a computer. We add a negative number. So we can add, we can multiply, we can do shifts, we can do negations, and we can do compares. These are all things that we do. So when we subtract something, we're actually going to add a negative number. So how do we do that? Well, the way that we create a negative number is that first we do the complement and then we add 1. And so there's our twos complement. So the example that I've got here is converting a 1 to a negative 1. And we start with, however many bits your system is. This is 8 bits, for example. So there's the value of 1, all zeros, and a 1 in the last binary digit. We reflect the pattern. That's our ones complement. And then we're going to add 1. And we get all ones is our pattern. And now that means negative 1. Now this actually is a little trickier than it looks. The complement is pretty easy, but now we have to realize that the high order bit, the one all the way on the left, indicates the sign of a binary value. And then if you want to fool around with this just for fun, you can actually do this in your calculators. And I've shown you the Windows calculator on the bottom for 1 and a -1. Well, there we have it for network math in this video. We've done the complements. One last note before I leave you with this one is that why do we work with complements at all? Why not work with the actual values when we're doing things like checksums? Well, it turns out that computationally speaking, checking for all ones or all zeros or calculating all ones or all zeros is actually pretty straightforward, pretty easy. Well, thanks for watching. Thanks for listening. Like and subscribe if I helped. And don't make me say it if you want to leave a compliment. And hey, may those packets always reach their destinations. Whether you're using the ones or the twos complement, you'll probably use the ones complement. And I'll see you in the next one.